Hello, welcome to Enlightning. I'm Whitney and I'm here with Ragid, who's going to teach us about OpenFGA today. Will you introduce yourself, please?
Hey Whitney. Hey everyone.
Hey.
So I'm Ragid. I am one of the engineers on the OpenFGA team. Joined the team like around 2 years and 8 months ago, roughly now. Yeah. To go a bit further, so right now I'm in Toronto, Canada. Before that, I worked at at a few startups in Canada. Before that, I worked on a few startups in Lebanon, back home, and that covered like various aspects of not all of them were they covered like B2C and B2B and various aspects of the security space. And now here I am.
I'm so glad you're here. It's so wonderful that you're sharing your time and your expertise with us. What a gift. One thing we talked about in the pre-show is that you told me that you're in the authorization space, and you told me it's common for people not to know the difference between authentication and authorization. I didn't know if that was just me because I'm a super noob or whether it's like a thing. So, so thank you for validating me. And maybe it's worth saying right now then what the difference is when you say you're in the authorization space. What does that mean?
Absolutely. Yeah. So when we talk about authentication, we're talking about validating someone's identity. For example, someone's logging into YouTube. The act of establishing who you are, that this is Whitney, that's the authentication. Think of it when you're showing your passport. Like, it's just proving who you are.
Okay.
Authorization is the act of whether you can perform an action or not, whether you have access to an action or not. So can Whitney view the stream?
Okay.
Either yes or no. So now it's, can you perform an action rather than or do you have access to perform an action versus who you are. So the identity authentication, auth-n, deals with establishing your identity, versus authorization establishes what access you have.
Excellent. And then for both of those could apply to either people or processes, right?
Absolutely, yes.
Okay.
So authentication or auth-n, yeah, you can have you can issue credentials to, for example, to people. or you can issue credentials to services, machine-to-machine credentials, where you're established. Well, maybe the YouTube backend can talk to the Google Contacts backend so that it can auto-suggest your contacts, something like this. So that's like in the authentication, like issuing machine-to-machine credential, but in the authorization space, same thing applies. Because you can have two services talking to another, like, and maybe both services are not allowed to do everything. They don't have full permissions, so you still need to check what access do they have.
Cool. Let's talk about something fun for a little bit while we wait for people to come, and then we'll move behind the board. One thing we were talking about in pre-show that I thought was fun was like how enjoyable it is to completely fail at something. Right? So not even necessarily something technical, maybe less so with something technical, because you're like, hey, wait, I should know this. I have something at stake here. I feel bad about myself. But like putting yourself in completely uncomfortable situation so that you can, I like doing part of, besides just enjoying feeling ridiculous, I like the feeling that I'm pressing my boundaries enough that like I'm really trying a brand new thing. But yeah, that feels nice.
I feel the feeling of discomfort, like I don't want to say discomfort, just slight, like it's out of your comfort zone. It feels like you're growing, like just
yes,
like you're not learning something new. You're doing experience that's new. It's like you're growing your boundaries in a way that staying in your comfort zone doesn't. Like there's space for both. Like people can stick their comfort zone in some cases, but like sometimes, like.
Growth is uncomfortable. Accelerated growth is especially uncomfortable. The more you're growing, the more it hurts. Hello to Code with Sean. And y'all in chat, will you please say hello and where you're from? If you want to, tell us a time you've failed miserably recently. I've been taking a dance class and I've been doing pretty terribly at it and having just a marvelous time. I'm going to go ahead and bop on behind the light board. Hi to all the friends who are here. Also, and I guess a more serious question for those of you in the chat is like, how are you managing authorization? And if you are doing it, are you concerned about people or workloads or both? Yeah. And we got a hello from Halifax. Ha! And Code with Sean says last time they danced, it was so bad that people thought you needed medical help. Hello from Montreal. Nice. Another Canada friend. Cool.
Go Canada.
And yeah, so tell us about your authorization. What's going on with that? Not authentication. Although if you want to share about that, we're here for you. All right. I'm going to mosey back. And then Ragged, will you share about, what should you share about? Maybe let's talk about the OpenFGA community and assuming it's cool, how cool it is.
Cool.
You're probably not the person to go to tell us it's not cool, but I would like your unbiased opinion. You heard it here first. Hi from Germany. Cool. All right, take it away. I'm gonna move.
So completely unbiased opinion about the OpenFGA community. Like this is like according to science, it's the best thing ever. Like, we have. It's been honestly very lovely to see it grow. We started with when we started open source this project early on. We started having more people coming in, more people asking questions, showing their use case, even before this project, when it was in the ideation phase. And we were doing a lot of talks with people to understand why, like how they're doing authorization and why. And when OpenFGA was open sourced, the community kind of skyrocketed, like in terms of compared to before, in terms of people's willingness to come in and contribute. Like it brings the best of the open source. The fact that they have questions outside of the core team, you have now knowledge of the code base outside of the core team, which is really something we would want to see a lot more of. Not just because we don't want to do the work, but we want this project to grow beyond us. We can go into this later, but part of why like Okta and Auth0 donated this project to the CNCF is we want this to be more than just us. We want this to be shared. We want authorization needs to be solved, and what better way to do that if not in the open source space, where people can collaborate and like do this together instead of the person doing it alone and it not being reusable or reshareable, and like no one benefiting from what everyone else is doing.
One thing, so I only caught the end of that, but one thing in that I understand, so just to give folks who are new here, I'm relatively new to tech. I just joined, I just got my first job in tech in 2020. And so one thing I hear a lot, but I've not experienced firsthand, is like the cloud native community is like especially kind and warm and welcoming. Do you have any experience with other communities not being that way?
So not being kind, like definitely you have several personas in the community. CNCF is different because it's of course backed by several organizations, but in several cases you have people who are more opinionated about how the project goes and should be. And that's not necessarily a bad thing. It's just a different way of management. Sometimes you do need leadership in terms of keeping you straight, keeping you after goal. But unfortunately, sometimes that devolves when you get various strongly opinionated people trying to collaborate. Sometimes it does evolve into a bit of unfortunate mishaps and like a bit of agitation. But in general, the open source community as a whole is insanely good. Especially like don't think about at the organization level, but at the individual level. All the individuals contributing their time basically for free, just because they think this is something that it could either benefit them, but the idea is it benefits everyone else too. It's just it's a beautiful thing to see, and
it is beautiful. So I want to say hello to Armando. Good to see you, Armando. Hello. Here we are. We're ready to do the thing. Let's do the thing. So I would love to start this conversation about OpenFGA. I know really next to nothing about OpenFGA. And what I would like to know is, what was the world like before OpenFGA existed? Like, what problems were out there that caused it to need to be created? And that's helping it gain so much popularity so quickly.
So I'm gonna, I don't want to say steal, but borrow my manager Andreas's phrase. Like authorization here is where authentication was like 10 or 15 years ago. Where we did not have a standard. Each one was doing their own thing, and suddenly there was this immense research and growth into like JOTS came out. Now you have like proper auth scopes. SSO now works. A lot of that was not available back then, and this is where we are in the authorization space in a way. Definitely there's a lot of previous authorization tools available, like whether ACLs, you have RBAC, you have ABAC, and we can talk a bit more about specifically RBAC because that's where like a lot of people coming into OpenFGA are coming from. So what RBAC is role-based access control. The idea that you grant someone access based on the role in an organization or the role in the system. So let's say you're a manager, therefore you can approve expenses, let's say, which is good. It's way better than we had before. Especially when it fits in with authn. So the issuer would inject these roles that you have in the token. which makes it so much easier. The problem is it's very coarse grained. Like, is it really that the manager can approve any expense? So generally you have to add to that a lot of application code, where after you get, oh, this person is a manager, you then want to get, oh, are they this particular person's manager? You do that in the app code, you'd hit the DB and get that. And that's how a lot of things work, which means, okay, we've at least abstracted away some things, but our app code is still doing a lot of logic, which ideally it shouldn't be.
Okay. So what I'm hearing is, before OpenFGA, there were no authorization standards. There were lots of tools available, but that was kind of overwhelming, maybe it sounds like. And then there's role-based access control exists, but it's coarse-grained.
Yep. Okay. Now, after role-based, we have attribute-based, which is way more fine-grained, if you will.
Okay.
Based, because what attribute-based is, now we're authorizing on attributes. So if the label is X, if this label draft and it's labeled marketing, then you have a role of marketing manager, then you can publish it. So it's exciting how we can add all these sort of stuff. And we have, there's definitely a very open source, some within the CNCF community in terms of to like manage those policies and like add that sort of authorization.
Okay, so I want to write that down, but before I do, I think I want to close this thought. Like, we captured the problems, right? We got it. And then I think I want like a nice definition of what OpenFGA is, and then we'll dig into these more granular concepts that you're describing with the attribute-based access control. Yeah. So we have a question in chat too. So let's go ahead and get that. So this is from AJ. I'd like to hear your take on the use case for OAuth scopes, when basically all of Auth-Z is modeled in a fine-grained way.
Yeah. So
it's a little over my head.
So there's auth scopes in general they're gonna remain a problem, because there's only so much you can fit within a token. So if you have access to 1,000 documents, 10,000 documents, there's only so much that can fit in that document. There's attempts at like updating that and adding more features to allow basically the server to get those permissions after it gets the token. But that's where you go into, why not just go with something more streamlined? Not that I'm saying that there's no use case. There's definitely a lot of use cases. But in general, token, like, and having scopes in your token leads to token bloat. It becomes too large, which means, remember, tokens are sent at every request. So like, it's in your sadly called authorization header. But that means every request the user is sending now has that. You're sending a lot of unnecessary data. But additionally, at some point, if it grows too much, some proxies might block it. Like this, if this request becomes too large, they'd start blocking this as malformed. Unfortunately, that's where it's just not as fine-grained and does not allow you to go into the minute details of, you can, like, oh, these are the 10,000 documents you can edit, and these are the 5 folders, and these are your 10 followers. It just makes it a bit harder. Yeah. Right. I can say a bit more. Yeah, one thing is also with a lot of these is sometimes you want the flexibility of, okay, what can this user do? Like, you want that list, but sometimes you want to start from the other side. Like, okay, what users can do this action on this object? Where this is not really possible with scopes, because you're not starting from the user, you're starting from the object. So things like this.
Oh, I'm getting a preview of what. So let's say, what is OpenFGA then?
Okay, so OpenFGA is a high performance, flexible, importantly, flexible authorization engine. It's mainly built for developers. It makes it easy for them to model their application permissions and like integrate fine-grained access control. It is both an API, so it can be run as a standalone API. You send HTTP requests to, or as a library you bundle in with your service. It has multiple storage adapters. Right now, we have Postgres, MySQL, and not production. We have in memory. We will be open sourcing a Dynamo DB adapter at some point. We have various SDKs that talk to this. We have a CLI tooling. So all that ecosystem is the OpenFGA ecosystem, but OpenFGA itself is the core API and the core library that you can use.
Okay. So I got a small fraction of what you just said, but we'll rewind and get it all. So OpenFGA is a high-performance, flexible authorization engine, and then
built for developers.
Mm-hmm.
To enable their to enable like fine-grained authorization at scale.
Great. Awesome. So it scales well and it's easy to consume by developers.
Yeah.
And it does fine-grained authorization.
It's important to note, like the developers. So we don't have a UI for someone not a developer to integrate, to like drag and drop their what their permission look like. But we could be working on this. Like there's definitely a lot of growth here. But at the moment, we're focusing on developers. Like everything is consumable by an API. The only graphical interfaces we have are more tailored towards learning rather than production management.
Okay. So right now it's consumable as an API in a library.
Yes.
Okay. Tani was here, which makes me very happy. Those databases you mentioned, are they storing data for OpenFGA, or are you protecting those databases with fine-grained authorization?
Oh, that's a great question.
Turtles all the way down, yeah.
So these are the plugin adapters that we use to store data. And we can go a bit later on about the need for us to store data compared to other solutions. But yeah, so we store like the OpenFGA data. It can be stored in any of these database adapters. And like this is important when we say data, because we need, for OpenFGA to function, it needs the data, like especially to reduce latency. Latency is crucial here because now, and we'll get into that later in how you're doing checks, but basically you'll be calling OpenFGA at every request. Whenever someone tries to perform an action, you will be checking with OpenFGA, whether through an API call or gRPC call or like just in the library, is can this user perform this action, which means that additional latency applies to each and every request now. So a way to minimize that means we need to store the data. So they're not in your application database. You need to give us your authorization data, anything related to authorization. And we need to store it as close to the service as possible.
There's a lot of, in terms of the Lightboard piece of this, there's a lot of directions, a lot of cans have been opened that we need to sift through. But I think maybe the one to start with is to dig into this, like what it means that the authorization is fine-grained, which seems to be related again to that attribute-based access control. So maybe now's a good time to write about attribute-based access control.
Just to clarify, OpenFGA is relationship-based. So attribute-based is a previous iteration.
Okay.
Not so it's one of the how things were or are now. So attribute-based takes things, makes them fine-grained to a lot of, based on any attribute you can now fine-grain. But that has a problem. So attribute-based has a problem, is you need all the data in terms of attributes. So if you send, let's assume like any manager can approve an expense for someone way down the line. So a managee's expense report. To do that with attribute-based, you need the policy, which you can get it. But then your app code needs to go to the database. Okay, I have this report. Who created it? And then go back to the database, find their manager, and keep getting all the managers way up the chain. That's in your production database. Finally send them to the policy execution, and which will tell you, okay, if this person is authorized or not. So it's way more fine-grained, but it's way more efficient. That way it doesn't work at scale. That's why at scale is important. At some point it breaks down, because it means like there's a lot of logic you have to do in your app code, and a lot of DB requests that have to happen in your application in order to find the decision.
So I definitely want to, I want to capture this data management, the relationship data management, or just more about that. But for now, let's explicitly say what it means that it's relationship based. What is that?
Absolutely. So for OpenFGA, it's on actually a paper by Google that describes how like authorization at their end works, like YouTube and Google Drive, that came out in 2019. So, and it works by storing things as tuples, as relationships. So a user is related to an object. So for example, it could be, the user does not have to be a physical active user. The user can be any other object in the system or group of objects. So like a folder. A folder is a parent of a document. That's a relationship. That's how these objects relate to one another. You can have someone be a viewer of a repo. That's also like, notice it's that sort of really like we're expressing relationships now. That's how we're adding the data or facts of the system. It can be like this organization is the parent of that other organization through an acquisition. That's also two objects related to one another.
Okay. So one example of this org is a parent to another org.
Yep.
This other org. And then what's another example?
This user is a manager or an admin in the Contoso org.
Okay. As an admin, I'm going to say in the marketing org. Cool. And then how about and you said it can be related to two other users?
Yeah, so you can say like in the X or Twitter world, you can say a user is a follower of another. That's also a possibility. Like that's
okay.
You have like the object is a user and they're just following another user.
Cool. Whitney is a follower.
Or an
a ragged. What?
Or an influencer.
No, I follow you. Cool. Is there more that we should say? So an object could be another user.
Yep. And one more thing we can say is it also can be a set of users. So you can say the members of the marketing admin group are related as managers of this folder or owners of this folder.
Could it also be a set of objects?
No, so it's always targeting a single object. Yeah. Yeah, and important again to reiterate that by user we don't mean like a person. It's just like the principal, the actor. It could be just any other object or set of objects. one other thing that that OpenFGA supports is, like, it's a special case, but we don't need to write it, but we can talk about it. Is we also support something saying like, okay, all users. So think of like Google Drive when you want to make a document public. So you can say all users are viewers of this document, and that's also possible.
Okay. So a user that's not necessarily a human has a relationship to an object. It could be a set of users, but it's always targeting a single object.
Yep.
Great. And then the other thing that came up already that I feel like should be captured is probably this data management. This relationship data used to be stored, it sounds like, within a production database, but now it's being stored separately in some sort of thing managed by OpenFGA.
Maybe before we get into that, we can talk about how people can use this, just because this goes into before we go into data and like why latency is important, is how would you check here in OpenFGA world? So
okay.
So in the OpenFGA world now, whenever someone's trying to perform an action, you would call check. So you would say, again, the same way we said, okay, you have a user, you have a relation, you have an object, you would check on that same concept. So can Whitney view Reddit's posts? And it's the job of OpenFGA to know that, okay, because you've previously told us that Whitney is a follower of Reddit, then Whitney should be able to view those posts.
So what you're saying now is how OpenFGA does checks.
Yeah, it's the paradigm of you need to change it from your application is getting the scopes from the token to it needs to actively call that other service and check on whatever action is trying to be performed. Every API call. Now,
what in the past, the access piece would have come from an access token.
Yeah.
But now with this model, it's not access token because that could be token bloat.
Yeah.
But instead, there's an API call being made asking, is this thing allowed to access this other thing?
Yeah.
Okay.
So you still get the user's identity from the token because we're not an authentication system, we're an authorization. So get the user's identity from the token, know who that person is. You already know what the action they're trying to perform. So then you call OpenFGA on that.
And it's called an access token, or is it called an ID token in that case?
So as far as OpenFGA is concerned, it doesn't care. So it's the application's job is to get that user ID from wherever it needs to, and send it to us. But it can be just like a random hard-coded thing. We don't care.
Okay.
We get a user.
So from wherever, probably a token.
Yeah.
And then calls an OpenFGA API. Is that called like a certain name?
It's the server or the core server we call it. Yeah, the server.
Okay. To discover whether
a person is allowed to, like, should we block them or should we allow them to continue performing the action they're trying to perform.
Okay. Whether the human or process.
Yeah. So whether we have we have a machine to machine, a service trying to perform an action like delete users, or we have a user trying to create a document, both of those, before they happen, the service would issue a check. Can this user actually do this? If yes, proceed normally. If no, block them. But this brings a very interesting, cool thing, is now you can actually move, because the first thing is you need just the ID. You can move all that authorization out of your app into even a load balancer. So the load balancer could be the one that's actually performing the check calls, not your app. Which.
So in the past, the access part was in an access token, and then the relationship part was hard coded into the app.
Yeah, or in the ABAC world, you would gather, like the application itself would have to gather the data needed from the database and sends them to the access policy, but it has to do that. So your application has to do that data gathering.
The logic, the relationship data gathering, related data gathering. I think that's worth capturing. So this is like, I'm gonna write versus hi Koromaju. Koromaju's here. Koromaju and Taniwa are both great question askers, so I'm super psyched. Versus, so paint me a picture of how it happened and or probably currently happens in other strategy.
So in other strategies, and I'm going to focus on the attribute base right now because we established RBAC. Does you have to do a lot of that in application logic. In the attribute world, attribute-based policy engine world, or you have a policy somewhere that says in what cases you're authorized, but it needs data because the data is not collocated. So you need to go to your database. You receive a request. Whitney is trying to like a post. You have to go to your database, find the post, and who the creator of the post is. Then find if Whitney is a follower or not of the post. Get all that data, send it all to the policy execution engine, which will then, based on the policy you told me you wanted to check, based on the data you sent me, then authorized or not. But there's a lot of logic happening here at runtime, at check time, the point for making a check. That's where all this logic is happening.
And perform logic about relationships.
So the key point is OpenFGA has this data already. You've already told them this. Whenever it happens, I don't think we haven't touched on that. So in OpenFGA, whenever something happens, you have to tell it. So the second you follow someone, you would update OpenFGA and say, okay, Whitney is now a follower of Shakira or whoever. This would happen at the time of an action happening, not at the time of check. So whenever the fact gets updated, you send it to us.
So this happens at runtime. That's not really the right thing. Yeah, runtime.
Or at like check time, if you will.
Yeah. Yes. At the moment access is needed.
Yep. You're way much better with words.
Thanks. Okay. And so this happens at what time instead?
So in the OpenFGA world, the data is sent to OpenFGA. It changes. So when you become a follower, Twitter would send us, or sorry, X would send us, okay, this person is a follower. Not at the check. Like whenever these facts are being updated, you're constantly feeding them to OpenFGA, so that when it happens, OpenFGA already knows all this. Already doesn't need to go gather, your app doesn't need to go gather data. OpenFGA has everything it needs in order to reach a decision.
Is relationships and everything it needs? Relationships it needs to make a decision.
Yep.
Is that okay?
We call them relation tuples. You can think about them as the facts. Like that. Those are the facts that are.
Them's the facts to make a decision. Okay. Cool. The value of this is becoming very clear to me.
I hope so.
That's the idea. Cool. So did you want to say more about data storage? Or we kind of covered that here, I suppose.
We can, yeah, we don't need to write down, but like this explains why we need to have data storage, like where it helps, because it's sending us the data before, like as it's happening. That means when a check is called, your app no longer needs to understand what data it needs to gather. So the logic happening in your app. But also the latency is way shorter because you don't need to go and gather all this data and then send it all. It's just sent once when it happens.
I think that's probably worth writing down, like the benefits of the way OpenFGA does it. So let's make it green. I made the P too big. OpenFGA process.
So for OpenFGA, again, because we're trying to target scale, so an app, a small app, we're trying to make sure this works well at scale of nesting. So think of, Google Drive, where you can have a folder with 100 subfolders nested in each other and the document at the end. That requires a lot of computation, but also in scale of a lot of check requests, because now we're authorizing on every call. That's a lot of check requests. So the more we can minimize data collection that's happening at check time, the better the better our latency numbers are. So
the relationship computation is done earlier, not at check time.
So the relation storage is done at not at check time. The computation is done at check time, but can be optimized. So you can have an index, for example, if you're willing to handle a bit of eventual consistency. What you can do is you can pre-compute some things and cache them. So some of these really nested relationships and cache them. That would definitely drastically help your latency numbers.
So is that worth writing down?
I think, I don't know if it leaves a lot of space for what we're going to cover, but yeah. So we can write it down.
So the benefits of doing it this way, relationship computation can be done beforehand. How about that?
Yeah.
Okay.
And data gathering. So relation computation can it's a possibility. Data gathering at check time is no longer needed, so the app is no longer required to go look for this data in their production database.
Will you repeat that, please?
So the data gathering is no longer required at check time.
I love it.
You don't need to go in your database at that point in time and go find out, okay, who are the parents? And another thing, this means you can remove some logic from your application, because that logic of trying to find all that data is now gone. You've separated it onto at write time, just update us. So whenever something changes, sorry, when I say runtime, it's write time is when something changes, just write to us, tell us. Someone is removed from an organization, just delete that person, send us this person, no longer member of this organization. A document is added into a folder. Folder is parent of document. Just as you tell us these as they're happening, so that you don't have to go collect them when a particular check happens.
Love it. Great. Do you feel like that captures the benefits of the OpenFGA process versus the attribute-based process?
Absolutely. Yep.
Cool.
This captured, of course, some benefits. When we talk about other benefits, there's a lot of them, but yeah.
Some. That's yeah. Cool.
But it does come with downsides, though. One major one being is now you cannot authorize based on any attribute. So if you want to authorize on a label or something like this, OpenFGA, now we've recently introduced the concept of conditions, which helps with that. So you can, to a certain extent, use them, but there's still other there's use cases for both. Generally, if you want to go with OpenFGA, enables more fine-grained at scale. ABAC is more flexible, but it's more it's less performant, we can say, and harder to integrate.
This is called ABAC, attribute-based access control is ABAC.
Also known as policy-based access control. Yeah.
Okay. And then, cool. ABAC, ABAC. And so we have a question, but before we get to Taniwa's question, I wanted to, so the drawback is OpenFGA only makes decisions based on relationships and can't make decisions on something like a label.
Yes, exactly.
What a label seems like a specific thing. What's a more general way to say that?
Basically, any generic attribute.
Generic attribute.
Or any attribute, yeah. Although this is no longer true because we recently added support for some ABAC-based ways. So you can now send some attributes.
Okay.
But it's definitely not as it's not like you can't go and write a policy in OpenFGA that uses all possible ABAC combination. It just would be nonsensical at that point. So if you have extreme ABAC use cases, maybe you'd be better fit with using OpenFGA along with the policy engine.
Okay. While I write this, let's get to Taniwa's question. How do you deal with intermittent failures that cause the sync to fail? So if someone follows and suppose the call to OpenFGA fails due to network connectivity.
So this is definitely something is solved in several ways. One, you can try to treat them as a transaction. So at write time, if something fails, of course, after retries, so we have in our SDKs built-in retry mechanisms and all that. But if you you can think about them as a transaction, send them, and if one of those requests fails, you revert the other. The other is some other people put them more in a queue, in a Kafka queue, and then have a process that would continuously keep updating OpenFGA with that. So it's separated from your app code, but still you have a different worker writing those data to OpenFGA. That would require that you're okay with a bit more latency, because if you have a queue, you're putting data in a queue, that queue may get out of sync. So if you're okay with a bit more latency, not latency, a bit more eventual consistency. So it'll take a bit of time. It may take a bit of time between an action happening and you sending it over to OpenFGA. But that means all your error handling logic, all your retry mechanisms are happening in the single space, in a single place, in a separate service. But do note that we don't handle that for you. So we just provide the API. Our SDKs do handle the retry mechanisms for on 500s, on 429s, all of that. Our SDKs handle them. But if you shut down the OpenFGA server, for example, we do not have a queuing system. You have to build that yourself.
Awesome. This is fun. What else you got for me?
What else can we talk about? So we can talk about some of the use cases this enables.
Okay.
Where can you use OpenFGA? And because there are many, so I don't know if we're going to write them all, but there's a lot of use cases across different spaces.
Okay.
In the these days, especially when you have more people care more about privacy, auditors and governments care more about not having too broad of permissions. Anytime people are more going towards more fine-grained authorization. I don't no longer want to give you access to the entire folder. Now I'm giving access to some things.
Yes.
So we're seeing it a lot more in this current ecosystem we're in.
Yeah, least privilege access, zero trust, all of
exactly. And that means like, and any app that does anything to do with sharing, so Twitter, Google Drive, Miro, any place where you can do sharing, the potential of that is easily unlocked by OpenFGA. Because now you can share not just the top level folder, like, and you don't want to do this in your app code. It's as simple as writing that data to OpenFGA, and then when a check happens, okay, can this user read this document? Your app code no longer cares why this person can read it, whether this person is an owner, is a member of a different org, or whether this document is public. The app code doesn't care about that. All it cares about, can this user read this document? And so all that sharing is now made insanely easier. But that's not just like, that's a great use case. Anywhere you have sharing, that share button, OpenFGA is a great fit. But there's other use cases. For example, think about the finance industry. When you have investors and you have some people, investors are very, like, you shouldn't see everything for each investor, especially when you're talking about like millions and billions of dollars. So each representative is allowed to do some have some visibility, not also themselves or the VC may have access to more things. Some have access to only some portfolios, even within the same organization. Now, when you have that, all of that, and like you're having this important across organizations, maybe you're delegating access. So all of that can be done easily with OpenFGA. Similarly, in the HR world, so think iCIMS or what's the word? Sorry, I forgot the name of that company. Greenhouse, I think.
Of what?
It's an HR like tooling, but similar thing. Like the interviewer maybe should only be able to view the profile of the person they're interviewing, not anyone else.
Yes.
Only some people are able to approve. Not everyone is. We can go further, like collaboration, Slack. Guests. You have an enterprise. In the enterprise, there's organizations. That is also who can post to a channel. Are the posting to a channel locked or not? Representing that in OpenFGA is honestly fairly simple. It doesn't take a lot of effort. We can talk about a bit more like anything to do with multi-tenancy, anything to do with having organizations having other organizations as contractors. It's as simple as saying, okay, I'm sharing this resource with the members of that org as viewers. That's one fact you write to OpenFGA, and it's done. Literally, all the members of that org can now access it. It sometimes feels magical, but so yeah, it definitely has a lot of use cases in the B2C world, but also in the B2B world. Multi-tenancy is extremely easy to model. What else is there to say? That like that's the idea why we stress flexibility. It's a flexible modeling language that can be used to express a lot of wildly different use cases across the board.
Cool. So I think part of understanding why this is cool is, again, understanding the before times that maybe a financial institution would just give a financial advisor all of the financial data for a certain region, when now they only have access to the ones that they're assigned to, or something like that.
And yeah, same for Google Drive. Before that, like if you think of applications a few years back, you can share a folder, but usually they would not let you have nested folders. So you have a project, but that like version of projects belonging within projects. That was not possible. So you can make it work through a lot of app code, but now it's almost given to you for free.
I think that's worth writing down. Sharing nested folders or like
nested resources, I guess.
Yeah.
Like, you can think about it like also you can have nested teams, so it doesn't need to be folders, like nested anything.
At any level.
Yeah, that's exactly it. Yeah.
Cool. Do you feel like apps that enable sharing like Google Drive or Miro, delegating access of sensitive information like financial institutions or orgs that give access to other companies, or sharing nested resources at any level?
Yeah, and you can think about it like also some apps have like kind of like impersonation, where a system user can impersonate another, or a support engineer can impersonate with maybe restricted permissions, cannot maybe edit all their org, but can go and see some things. That is also like a very good use case, because now you can say, okay, the support engineers in this platform, if they're given, like if there's a ticket, can go and perform these actions.
Access only what they need for their open tickets. That makes a lot of sense.
Yeah.
Awesome. Cool.
Maybe we can talk a bit more about what. So, okay, we're talking about OpenFGA. What it would need to integrate. Like, okay, we're talking about all this, but we can talk a bit about we talked about the data. So, right, in fact, but OpenFGA requires one more thing. Kind of think about it like the model, the representation of what all the types of objects in your system are. So you have folders, you have users, you have organizations, you have clinics, like you have maybe rooms, all that stuff, and how they could possibly relate to one another. So you would have, for example, organization has a relation member, and that is given to only users. And a document, you have a relation of parent, which is another folder, but you'd also have a viewer, which is a user. But then you can also have relations which are implied. So can view or can edit is not it's not something you assign. I don't assign you as like can delete and can edit. I just say you're an editor. And those permissions are implied because you're an editor, or inferred you have these permissions. So needs this data, this model, and the data. So it uses the model to traverse the data when a check happens, in order to reach, like if it can find a path from the user to an object, then you're allowed. If it cannot find a path, then you're not allowed. So the model would help it kind of traverse all that data you've sent us.
So shall I write about the OpenFGA relationship model on the board?
It's definitely yes, it's definitely a big factor in what OpenFGA is.
Let's write it down. I'm gonna say hi to Tarek. Hello, Tarek. Hello from Toronto. Hey. Let's write it on. Let's write like what it is, like a definition of what it is, and then give some examples, if that's okay.
Yeah. So
would it start with OpenFGA relationship modeling is?
So you can say the OpenFGA just model. Yeah.
Okay.
Or the authorization model.
Okay.
So the OpenFGA authorization model is like, first of all, it's static. So unlike the data, which is changing as
okay.
static, and it's a representation of the types of objects in your system. And how they could possibly relate to one another. Which means you can, things like, oh, editors are also viewers. This happens in the model. So any permission you give to a viewer, a viewer is automatically given to editors. Same that any permission given to editors are given to admins. So types of objects in your system, yeah, and how
okay, what?
And how they can relate to one another. So it's types and what are the possible relationships.
And then I think it's important to say that OpenFGA uses this model to traverse the data.
So yes, so when OpenFGA received a check request, OpenFGA uses this model in order to in order to traverse the data that it's been already given. So the facts that it's been already given, and try to find a path between the user and the object.
So it uses this model plus existing data.
Yep.
To try and find a path from the user, which is not necessarily a human.
Exactly. It's like from object or principle to the resource or object.
Yeah. Object being accessed.
And yeah, and as you wrote, like, it's important to note that this is static. So the model, you're not changing the model whenever something happens. You would change the model, for example, when you're introducing a new feature. You now have allowing comments. Comments is a new thing in your system. That's when you update your model to include comments. You want to split your roles. Like before you had admin, now you want to have like billing manager and user manager. You would update your model to include these two. But this is happening outside of your app. So this is you're just updating. You're just changing the model in OpenFGA, and your app, when it's checking, it's getting that for free. So it doesn't need to know about any of this.
Yeah, this is all happening in the in the OpenFGA side of things. And then I guess it's probably worth asking then, where's OpenFGA running? And is this meant to be for a distributed system, or can it be for any type of system?
So definitely it's great for distributed systems, but and it's great for, like, you can you can use it as a library. So you can run it in your app, or you can run it as a separate service. We have a Helm chart which you can use. So yeah, it works for both.
Okay, all the above.
But it is a separate. At least our main use case is a separate API service which all your apps would call.
Okay.
But using it as a library is also possible.
If you were to install it, what would be the process like? What is the process like?
So we're talking about CNCF. We were talking about the Kubernetes world. So of course, our favorite method of installation would be using our Helm chart.
Yes.
And, so that would be the easiest way. especially for the people in this world. If you don't want to go the Helm chart route, of course, you can use, I don't know, whatever works for you, Docker Compose or Docker, or just running it as a binary. It's a Go binary, so just running that's also fine. But if you're into Helm, check out our Helm chart and like install it from there.
Cool. You're getting some love in the chats from, we have Adrian's here. Hi, Adrian. And then a go Ragid from Andre. Thank you, Andres.
Andres is the person whose comment I stole earlier, where I told you authorization right now is where authentication was 15 years ago. TM by Andres.
I have a question as far as that goes. I've been learning a lot in this space, and it seems like Spiffy is a pretty hot topic in terms of workload identities. Is that, can you accept a Spiffy identity as when you say it gets the user identity from wherever, can it be Spiffy?
So maybe we can modify that a bit, because OpenFGA is not responsible for getting the user identity. So any identity is accepted by OpenFGA. It's for us just a string, a representation of the user. So any identity, whether it's we will accept it, but the person implementing it will need to do the translation of what does this mean, and sending it to us.
So you're like, here's the string that I was presented, and then the user configures like whether that string is an acceptable
we will accept any string, basically. So
cool.
So long as the string doesn't change, so long as it's a static string, that's a good representation of an identity for us, and people can use it.
Awesome. We're getting more love for you in the chat. I love it. That's wonderful. Thanks, everyone. So we're running out of space. How are you feeling in terms of all that you wanted to share? Whether it's getting
like 3-4 other boards is also.
Why don't you share what you want to, but direct me about what I should actually write down?
Okay. We talked about actually we did talk about like some of the major concepts. We can highlight some things about OpenFGA that are actually pretty cool.
Yes, I agree.
For example, we can talk about the authorization model, the fact that it is immutable, so it does not change. You cannot change it after you create it. It's a static thing. What you can do is like create a new model. The cool part is what that allows you is you can test things before pushing out to production. So you can write new models. Your production is not sorry, what was I saying?
The authorization model is immutable, and what that allows you is
if you're writing stuff, what you can do is write a new model, test it in against the production data, against the production data, but outside of your app, because all the data is now in a different service. The models are immutable. Once it's ready, you can then go update your apps to target this new model. You can also do things like A/B testing. So when it's ready, maybe you go to your app and you do shallow checks. So you check against your existing model and your upcoming one, and and monitor for any deficiencies or like discrepancies. If you're good, your confidence level now has a boost. That's when you go now do the full switch. This is important. Why? We're dealing with the authorization space. A mistake could be spectacularly bad.
Yes. With great power comes great responsibility. We have a question for you in chat.
Yeah.
So this is back to OAuth scopes. To my OAuth scopes question, I thought if your take is to drop these completely, because modeling is a global admin and just another relationship to the overall app tenant.
So you don't need modeling a global admin is as simple as having a platform and say as a relation, say user is an admin at that platform level, and that platform is a parent of a bunch of orgs. And then in your model, you can specify that. So that admin would get access to anything you want them to have access to. you no longer need to hard code things in your app or in the scopes in order to enable that use case. If you think this, keeping that framework where you have like is admin works for you, that's okay. But it's restrictive because, okay, you're going to have a few permissions and your app needs to worry about them. So your app at a check, your app needs to check, is this person an admin or not? Why bother? Just call FGA. Can this person, whoever they are, whether they're an admin of the platform or just a random viewer of the system, just call a check. Can this user perform this action or not? And that's all it takes. So in that, you can still use some form of scopes if you wish, but it's just like, why? So why do this app logic in your, or why do this logic in your app when you can just delegate to OpenFGA? Again, the potential benefits is your app no longer needs to worry about all this. Your app, all it cares about is just checking for the user, whether the user can perform an action or not. So it becomes way simpler.
We talked about OpenFGA versus attribute-based. Is it an either-or thing? Can you use a combination? Can you use OpenFGA for like relationship-based and then also have an ABAC available if you need to do the AE attributes, the label-based or whatever? Yeah.
So to talk in terms of policy engines, OpenFGA can just be another policy information point where you're getting some piece of information, but it's not the decision point. It's not making the decision. So you can use like something like OPA or any policy engine, and from that policy engine, call OpenFGA for one more information, one more piece of information, which is, can this user access this? And combine it with other piece of information in like are more attribute-based in OPA. That's totally doable. We don't, like, in that case, we're no longer the decision point. We're just an extra piece of information that the policy engine is using to reach a decision.
Cool. Cool. You have this much space.
Okay, let's see. What haven't we covered yet? A lot.
We also have covered a lot, for what it's worth. We've done both.
Yeah, thank you for your patience. This
is fun. I'm having a blast.
It looks pretty. So we can talk a bit about some, like, I know I want to talk a bit about, like, okay, the future, what that looks like, but I think keeping that till a bit till the end is better.
Okay.
We can talk a bit, I don't know if maybe we do not write them, but just for people following, we can talk on how we enable, like, if you are coming and want to use this. Okay, we have an API, we have a library.
Okay.
But we also make it easy for you. We have SDKs for 5 languages so far. So
okay.
Java, Python, JS, Net, and Go to help with modeling. So writing the model is sometimes can be it's hard. Like, not it's hard in terms of it's complicated, but there's a lot of tricky things in there. So, and it's easy to make a mistake. That's why if you use our CLI or our VS Code, they help you. The VS Code by syntax highlighting the CLI by writing tests. So you can write the model, write dummy data, like, okay, assuming this data, and this is what I expect, which is great because you can do all this. You can verify that you can model your application, your permissions, without writing any code. You would, before starting integration, before anything, before you would have a model that would work for your use case. So it would be like, okay, assuming I have this data and this model, this check should return true or this check should return false. And we're still building on that. We're hoping to come up with a kind of model coverage tool at some point soon that would help you say, okay, now I'm like, again, we're talking about building your confidence. When you go with authorization, we need you to be as confident as possible that this is what you intend and you're not accidentally like missing something. Compared to before, and like this is a great thing about like OpenFGA being a separate service, Before, to understand all this, you need to look at your app code. How you do not have this separation of data and the static. Is you need to look at your app code and try to figure out what's happening. You cannot run something separately because all the logic is contained in your app code. So a lot of this becomes harder. You cannot verify permissions beforehand. Also, we can think about in the future, like auditability. Now you can know who has access to a certain thing.
Yeah.
And like think about at some point, who has overly broad access. Work on reducing that.
I have a question. This authorization model, is it? I'm imagining like one big monster thing that like says every relationship to every possible other thing in an entire organization. Like, do people own pieces of it? How does ownership of the model work?
Wow, thank you so much for asking this, because I'm sure Andres was demoing this in our community meeting like an hour ago.
Oh, yeah.
Yes, the model can get big. The model does not have data, but it can get big because now, like, think of Atlassian, they have a lot of products, lots of relations, it can get lost. So one feature we're about to start working on right now is called modular model. And what it allows you is to split your model into separate files, and like it can give right now ownership you can verify through GitHub Actions. Imagine you can push you do a change to a particular part of the model, and in GitHub you'd say, okay, only this team is allowed to approve changes to this file or to this module or this part of the model. So that helps a lot in this case. That was a very timely question because but it's literally what we're working on right now.
So you told me not to write things down, but what this is safe for the future, and that's what something you're talking about is a modular authorization model for the future.
Yeah. So this is not out yet at this moment, but is going to be out hopefully like within the next couple of months. We also are working on a lot of things like indexing to reduce latency. We talked about latency, how important it is. One problem that comes with OpenFGA is understanding all the objects a user can access, or we call this problem search with permissions.
Will you repeat that one?
Like search with permissions, because
this is a future thing, right?
We have some way, like it's separated into several parts, but the biggest thing is still to be solved by us, with making it easier for our users to consume. We call this like the local index, basically. And what it would enable is being able to, because the data, to go back a bit, because the data is all with us, if you're trying to search, you're saying, okay, give me all the documents Whitney can view. What's going in there? There's sorting, because maybe you want to sort by recency or created. And we just said OpenFGA does not have metadata, so it only cares about the authorization data and the relationships, so it won't have all these attributes. Maybe you're sorting by something that starts with an A. It only has object IDs. So right now it's hard because, okay, you can tell OpenFGA, okay, give me all the possible documents Whitney can view, and then go to your database and see, okay, given this like subset, what matches our search criteria and our sorting criteria. But that won't work at scale, because what if you have access to 1 million? So what you will be able to do is have like a local copy of some particular aspects of the data that you need, and be able to do cross joins basically in your app. Like, okay, just give me that where the name starts with an A and they can view. There's also where we're seeing we want to do a lot of expansion in terms of see where the field goes into the future. So if you think about OpenFGA or authorization right now, we're trying to have at least some sort of, I don't want to say standard yet, but at least like some common language people talk through when they're talking about access. Like how when you say, oh, okay, authentication, we talk about token issuers and tokens and client credentials. That's like a standard now. Authorization does not have that yet. So our vision is at some point this will become, whether it's current form or an iteration of it, is like will be a common language that people can use to check for. And then think about it even more. So in authentication, after like figuring out the sign in, the next part was the employees and like having SSO. It like where your access is gated by one company across different products. And this is where we also see authorization going. Like there's now identity governance or from various providers where it can hook into the data provided by FGA and modify the data provided by FGA in order to be able to, when you're onboarding a new user, get access to these things, whether it's GitHub, like update their access on GitHub, update their access on Google, their access. If all of those were a common language, identity governance would become so much easier because you don't have to re-implement the wheel for every new service you're trying to integrate with.
A common language for each service.
Yeah. Those are definitely something. Some of these like modular models and search with permissions are near term. When we're talking about standardization, we're talking about like a bit longer term, but definitely it's in our vision. That's where we'd like to be. And to go back a bit, like when we're talking about the benefits of OpenFGA and like and the idea of a common language. If you think about right now, if you ask your team to implement authorization, in most probably each will do it in their own way in their app code, or if they're using a policy engine, each team is trying to do different things. Once we look at OpenFGA, now each team, all it needs to do is call check. So as your engineers switch between teams, they don't need to relearn all those concepts. All you're doing is the same logic, the same train of thought. Definitely, that's one of the power like of OpenFGA and like having a consistent language. The language you can just as we can say, can this person view this object? You can also ask, who can view this object? And at some point, we can ask, what objects can this person view? All of those are basically, so long as you can ask that question, know how to represent it, you know how to write it for it. There's no learning something completely different.
So it's easier to switch between teams. I could see two reasons for this, like easier in terms of easier to understand the application source, that code that you're working with, because it's going to be consistent. The implementation language, at least, or logic, the way it looks, it's going to be consistent between applications. But then in terms of like whatever permissions you need, because you're now on a new team, it might be easier or more transparent or auditable to grant those permissions.
But also a skill set. So if you think of the developer trying to implement those permissions, they don't need to go from scratch. Again, it's just a check. And other benefits include we talked about auditability a lot. That's definitely good. Being able to test the model is definitely good. yeah, and like separation of concerns. Like at some point, maybe the model can be handled by the platform team, where engineers only care about implementing it. So
yeah.
yeah.
Yeah. Yeah. I like this. There's a room. I can erase some lines and make a little bit of room here if there's more you want to say. I'm on your team. We also have some nice comments right now. We have a thank you. Everything is as policies and relationships seems more straightforward to our friend AJ too.
You.
And Taniwa says, "Yay! You're asking the best questions. Thank you, Taniwa."
Yeah, you are.
Thanks. Yeah, so I can make a little more room. I can, if this stays free, I'll fill it with hearts. But I can also write a FGA comment here, and then I can make some room where these lines are.
Yeah, actually, maybe we don't need a lot of room.
Okay. I have permission to draw hearts then.
There's a lot to talk about, but it's sometimes hard to tie it all together. Yeah.
You feel finished? There's no pressure one way or the other.
Let me take a moment to think if there's anything we haven't covered. No, I guess at least for now, this is it on my mind.
Amazing. So all y'all who have questions, if you have any more, now's the time to ask them. And in the meantime, what I'm going to do is a recap. So I'm going to recap everything you just taught me, and we can decide if there's anything to add and make sure I have a clear and therefore we all have a clear idea of OpenFGA, which we knew nothing about before today. So here we go. Actually, I have a question right off the bat. Does FGA stands for something? Fine-grained access?
Thank you for asking. Yes, so it's fine-grained authorization.
Fine-grained authorization. I want to capture that. FGA equals fine-grained authorization. All right. So here we go. Oh, Tanya Wall says, also notice you have to be here instead of your community meeting. So thank you.
Thank you. Yeah. And
yeah.
It's because of Whitney. It's good to hang out with you.
Oh yeah, I'm having a great time. Okay, so before OpenFGA existed, there are no standards around authorization, which for noobs like me, authorization is what you have access to once your identity's already been established.
Yeah.
So once you've already been authenticated to the system. There are lots of authorization tools available, and there's role-based access control, but it exists, but it's very coarse-grained.
Yep. We also have
attribute-based policy. Access control.
And yeah,
it exists. And yes.
And while these are like commonly used and like in a way not standardized, but are extremely common, they fall short because of everything we talked about. They fall short in terms of fine-grained and scalability, like that combination, because of what we talked about.
Yes. Great. So and we'll talk about that when we get to this piece of it. So OpenFGA is a high-performance, flexible authorization engine built for developers to enable fine-grained authorization at scale. So it can be consumed as an API or as a library. It also has SDKs to help with modeling, which we'll talk about modeling shortly. So OpenFGA, what it is it's relationship-based, not just role-based or attribute-based. So it stores relationships. And then, so basically a user, which a user is not necessarily a human user, it has a relationship to an object. It could also be a set of users, but the object is always a singular object.
Yeah.
And so examples of this would be like this org is a parent to another org. So this user is an admin in the marketing org, or Whitney is a follower of Orag. So I guess you have like a user, an action, or I guess a relationship name, and an object. So there are three things that you're defining in this situation. So OpenFGA, what it does, well, I guess I'm going to go with like attribute based. So this is helping the context and maybe the before times, or even like the other ways of doing things, which have different use cases, not necessarily inferior. Yeah. But attribute based policy engines, they have to make calls to databases to perform, and then to get like to understand these three pieces of information. And then they need to perform logic about those three pieces of information, and then decide whether to give access based on all of that. And all this logic, this computation is happening at the moment it's needed, which we're calling check time.
Yeah.
Check time. Which the time you would want to use this is if it's an attribute like a label or something that's not a relationship-based attribute. But then what OpenFGA does is it gets the user identity from wherever, so probably a token, but could be anything. And then it calls the OpenFGA server API to discover whether the human or process is allowed to do the thing. So the logic, the work, and the work of like finding all the relationships, like where they are and what they need, and then the logic of processing it is not in the application anymore. It's outsourced to the OpenFGA server API. So what OpenFGA stores the relationships it needs to make a decision. So again, these three things: the user, the objects, the relationship. Yeah. So we talked about the drawback. So some use cases for this, when it's good, are like apps that enable sharing. So we talked about Google Drive or Miro or anything like that. Also, it's probably worth saying like enabling sharing too. You're giving a user permission to give people access. Like that's one of the actions that you can do.
Yeah.
You can
delegate, or a group of users. You can say, okay, I want to share this with public or the member, like internal to my organization. Yeah.
Yeah, I feel familiar with that firsthand. Cool. And then delegating access of sensitive information. So financial institutions, for example, we talked about like a wealth manager maybe having access to everybody in their whole region when they only should. This way we can give them access to only people whose wealth they manage, or orgs that give access to certain things in their company to people at other companies can make sure it's very fine-grained access. They access only what they need and nothing more. Least privilege. And then we could share nested resources, and we could share them at any level, so with any amount of granularity. And then another example we had is like support tickets, who can access only what they need to be able to help their open tickets, and then nothing more than that. We talked about some benefits of the OpenFGA process over doing the attribute-based process. So the relationship computation can be done before check time and cached. The data gathering is no longer required at check time. So, and then the logic can be removed from the application. And then we also talked about for engineers who are working on an application, it could be easier to switch between teams because that authorization logic and skill set will transfer instead of having to understand how that specific application does it. Yeah. Taniwa has to bounce by. Taniwa.
One thing we forgot to write, but it's the auditing aspect of the fact that this is separate. Did we write that?
The auditing aspect?
Yeah, so where the fact that you can go and look for overly broad permissions and go and like understand how permission, like who granted a permission and why.
Okay, and that's
like part of the benefits you get, like as part of using a separate service like OpenFGA.
We did say that access is auditable.
Oh, okay. We did say that. All right. Sorry.
But
Yeah.
we can. Is that part of what transfers? You think the skill set that transfers?
No, that's like just a general like benefit, I guess.
Okay. Cool. Yeah. I think when we said the benefits, I didn't mean for it to be all the benefits. I meant it to be the benefits of this piece of it.
Okay.
But it would be, it would have been nice to collect them in one place. I'm sorry. Okay. So a big piece of this that's important to understand of how this all works is that we have this OpenFGA authorization model. So this is a static representation of the types of objects in your system and how they relate to one another. So again, the three things, the objects, and then the types of users, and then the different possible relationship types. So when OpenFGA receives a check request, it uses this model plus the existing data to try and find a path from the user to the object that user is trying to access. And if there's a path being accessed, if there's not, go away. So then because this is a static representation, this authorization model is immutable. You can test, that means you can test the new model before it's released and make sure it gives you confidence. And also the access to this model is the access is auditable. So you can see who has access to what stuff. I guess that wasn't perfectly clear on the board.
Yeah, maybe the idea that access auditable is not part of the model, it's just part of the system. The idea that you can call requests to the OpenFGA as a separate service and understand access, and also understand access as the model is changing, all that stuff. And in terms of auditing, maybe you can enrich, because you're doing a check at every request. It allows you to maybe enrich that with some, or the rights, enrich that with metadata, like who's granting access and why. So you can, we don't natively support that yet, but think about it. When I share a document with you, being able to, okay, you shared this document, that's why I have access. Later on, you'll be able to understand why someone has access.
Ah, nice. I like that. Cool. So then we talked about the future. So the modular authorization model. So this authorization model is a big thing right now. And if we have a modular version that works together, different teams can own different pieces, and that should be coming soon. Apparently just announced at the community meeting today. We have search with permissions. So in relation to like what's auditable, you could do something like give me all the docs that Whitney can view, and you can search more granular within that search too. And then so those two are near-term things in the future. And then we have a long-term thing, which is standardization around authorization. So like a common language for each to integrate each type of service that you might need to access.
Yep.
I think that is everything I wrote on the board.
That is great. Thank you.
Oh yeah. One thing I want to add is like the three actors in this relationship based, like three things. Yeah. Is actors the right word? Because we have a user, a relationship, and a object.
Yeah. The three fields, I would think. So it's relation and object, and all together they form a relationship.
Okay.
Yeah.
Equal a relationship. So we have user, relation.
Yep. And
object.
And we did say it somewhere else that a user can be anything, like as an actor, as a principal, as a subject. A user is an object, so it could be an object, which is like when you're saying a folder is a parent of another, like or a set of objects, which means like members of this group. So the set of members of this group are maybe viewers of this document. So user is either an object or a set of objects.
Okay. And an object is also an object. The object's being acted upon versus the object doing the acting.
So all of those are called, like, any type with an ID is called an object.
Okay.
In floating world, but in this field, an object can only be an object. You cannot say a user is an editor on like multiple at the same time. So in a single relationship, it's always a user, a relation, and a single object.
Thank you. Okay, cool. Excellent. I like capturing that. That helps my mental model to think of those three things discreetly. Awesome. I think that's a wrap, friends. You feel good?
Yay.
Yay. Okay. Did you do that on purpose? Wow. I'm so impressed. Okay, I'm going to replay our theme music and say our goodbyes. So, there it is. Thanks, Ragged, for being my guest and sharing your time and expertise. Thanks to everyone who watches the recording. I'm sorry, talking over you.
Thank you to you and to everyone who joined us and who will be the
Thank you.